Good morning, children. Today we are going to study chemical kinetics. Chemist is always concerned with in understanding the different aspects of a chemical reaction. There are three main aspects in the study of reactions. They are: number one, feasibility, of reactions, that is, whether spontaneity of a reaction, whether a particular reaction will take place on its own in a particular direction under the prevailing conditions or not. It is being given, it is being measured by the magnitude of Gibbs free energy change, that is your del G. For a particular reaction, if the value of del G is less than 0, that is, the value of del G is negative, then the chemical reaction will take place in that particular reaction under the prevailing reaction conditions. If the del G value is not less than 0, the reaction will not take place on its own. The second one, and this being studied in thermodynamics. The second one is, if a reaction is feasible, then to what extent the reaction will proceed before equilibrium is attained. This we study based on the magnitude of equilibrium constant K. For a particular reaction, higher is the value of K, greater will be the extent of the reaction before equilibrium is complete. And this we study in chemical equilibrium. The third aspect is speed, that is rate of reactions. It is very important to study the rate of a reaction, which we will not get up from thermodynamics or from equilibrium, chemical equilibrium. The rate or speed of reactions we study in chemical kinetics. What is the importance of the rate or speed of a reaction? We can take an example from our day-to-day life. Curdling of milk. We know that in winter season, curdling of milk is very difficult, whereas in summer season, it takes place in few hours. The reason behind it is the growth of lactobacillus during the curdling of milk takes place under warm conditions, not cold conditions. This is the reason that in winter season it is your time taking for curdling of milk, whereas in summer season, since weather is warm and which is favorable for the growth of lactobacillus, so it is your less time taking. Once the curdling of milk has been done, if it is not transferred to a lower temperature, then it will become sour due to the tremendous amount of formation of lactobacillus. Now we have to decrease the rate of formation of lactobacillus. That's why when curdling of milk is completed, it should be transferred to a lower temperature, that is, should be kept in freeze. So with this example, we know that what is the importance of the rate of a chemical reaction. If it is favorable, we have to take every measure to increase the rate of such reaction. If it is not favorable to us, then also we have to take different measures to decrease the reaction rate. So now, based on reaction rates, the classification of chemical reactions can be studied under 3 headings: extremely fast reaction, extremely fast reaction, which is your very fast reaction. Example is the reaction of silver nitrate solution with sodium chloride solution. We will get silver chloride, white precipitate instantly, and sodium nitrate. The instant formation of white precipitate of silver chloride explains that the reaction is very fast. The other example is your neutralization reaction. Sodium hydroxide solution reacts with hydrochloric acid. We get sodium chloride and water. Since these reactions are very fast, it is not so easy to calculate the rate of such reactions. The reason behind it is why these reactions are very fast, because these are the ionic reactions. During the process, there is no cleavage of bonds of the reactants. So, ionic reactions take place very fast. The other one is your extremely slow reactions. Extremely slow reactions, that is your very slow reactions, like rusting of iron in presence of moist air. This particular reaction, rusting of iron in moist air, is your very slow reaction, and it takes place before to complete even a year also. So, rusting of iron in moist air is a very slow reaction. That is, iron, here is your moisture, here is your air, oxygen, we get rust, that is ferric oxide, Fe2O3.XS2O. This is the rust. So, the rusting of iron, once started, to complete such reaction, even it takes a year also. Year 2 also, since the reaction is very slow. So, there is difficulty in determining the rate of such reaction. The third one is Moderately slow reaction. Moderately slow reactions. Here, the reaction takes place under measurable time, and the rate of such reaction can be calculated easily. Example of moderately slow reactions are hydrolysis of ethyl acetate. Hydrolysis of ethyl acetate in acidic medium, we get acetic acid and ethyl alcohol. The reaction rate is moderate, so we can easily calculate the rate of such reactions. Another one is your hydrolysis of cane sugar in presence of dilute acid. This is again another example of moderately slow reactions. Its rate can be easily calculated. Now,